Kia ora, Year 10. In this video, I'm going to go over what we mean by a sample space and how to find probabilities when we've got equally likely outcomes. So this video follows on from tree diagrams, but the content is actually kind of separate. Some notation and vocab that I want you to be confident with by the end of this video is on this slide here. So I want you to know what the sample space is. And I want you to know the difference between an outcome and an event. So basically, an event is a combination of outcomes. Okay, and the last thing I want you to be confident with is this notation that we use for finding probabilities. So if I say P bracket something, that means the probability of something happening. So it might be probability of the total being above 5 in whatever context I've got, right? So we write this P and then these brackets to show we mean let's go find the probability. Okay, I'm going to work through a couple of examples here, but there's a kind of way to think about probability that will help me a lot, and that is that the probability of something happening, of some event, can be thought of by saying, let's break our situation up into the total number of things that can happen, right? But those things that can happen have to be broken up so that they are all equally likely. So the total number of equally likely outcomes, and in the top line we want the ones that make up this event, and we just say that we mean the number of favorable outcomes. So you'll see how this works more easily once we do an example, but I'm going to give you that definition now, and I would like you to put that into your notes with a rectangular box around it that doesn't look silly like that one I've just done there. Okay, so we're going to use that in a second. So let's suppose that we've got a really boring situation. I'm sorry, it's boring. We've got 2 dice, right? And both of them are labeled 1, 2, 3, 4, 5, and 6. They're the usual shape. There's nothing funny about them. And I throw the 2 dice and I multiply together the numbers that come up. So I want to figure out what are all of the outcomes that occur. And then we're going to look at these 3 questions. So what's the probability that the numbers multiplied together are even? What's the probability that the numbers multiplied together are 6? And what's the probability that the numbers multiplied together are 20 or higher? So the best way to think about this is to do a table like this one, right? And across the top, we've got the things that can happen on the first of the 2 dice, which we call the first die, and here the second die, right? Really important that these things here are equally likely, right? And so are these things here. So when I take the 2 die and I throw them, if I get 1 on the first die and 1 on the second, and I times those numbers together, I'm going to get 1 times 1, which is just 1. Right? If I'm over here and I get 4 on this one and 3 on this one, I times those numbers together and I get 12. So you can see that there are 36 outcomes in my table, and they're all going to be equally likely. So what I want you to do now is we'll fill out this table. I'm going to pause the video and fill this out so that you don't have to watch me do it, and you could copy this down into your book because we're going to use it to do these questions here. Okay, so just fill up the table using the product or the numbers times together. Okay, so we should have all of those things in our table, right? So there are 36 different combinations that can happen. Right, so I could get a 1 on the first and the second dice, a 1 and a 2, and so on. And then when I times those numbers together, we're going to get all of the different possibilities. So what's the probability that the numbers multiplied together are even? Well, the first thing I do is I say, well, how many are the total number of possible outcomes? And that's 36, right? There are 36 different combinations of things that could happen. So we're going to have something out of 36, and then how many of those are going to be even? And so for this, I can just use a highlighter or check them off. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all of those, and then these ones here. So you can see some nice patterns in here. right? So you can see that it's not 50-50 that we're going to get even or odd in here. And we'll come back to that later in this topic. But if someone offered you the chance to play a game and said, "There's we'll share the money equally and you win if you get an odd number," then you would not want to take that bet, right? So just looking at it here, how many outcomes give me an even product? Well, I've got 1, 2, 3 here, 3 here. I've got 3 more here, 6, 9 here, and then I've got 18 here, right? So I've got 6, 6, 6, 3, 3, and 3. So 9 and 18 gives me 27 out of 36, which means that there is a 3/4 probability of getting an even number. Okay, so just notice how to solve that problem, I had to draw really the sample space diagram, right? It's showing me all of the possible things that could happen. And then this thing here is called an event, the probability that we get an even product of those two numbers. And we just count up how many outcomes are what we call the favorable ones, right? So from this slide back here, remember the probability of an event is the number of favorable outcomes. So that means how many gave me an even product divided by the total number of equally likely outcomes. So that's the first one done. Let's see what the other questions were. Right, what's the probability that the numbers multiplied together are 6? So this one will be a little bit faster to work out. We'll probably get 6 or something like that, right? So again, we've got 36 possible outcomes, and how many times do we get a 6? Well, there's one there, right? 1 6s. Or I could have 3 on the first die and 2 on the second, so there's a 6 here. Or I could have 2 on the first and 3 on the second, right? So notice that those two things are different, right? So we've got 3 possible outcomes out of 36. No, I've missed one, haven't I? I've got the 6 and the 1 here, right? So we could get 1 on the first and 6 on the second. Okay, so there are 4, right? So 4 ways to get 6 out of 36, and then I can simplify that fraction and get 1/9. Right, now the last one here is looking at the probability that the numbers multiplied together are 20 or higher. So I'm just going to clean some of this up before we go any further. So 20 or higher, let's see. Oh, I like that I can undo that. Right, so let's just do in green pen which ones are 20 or higher. So you can hopefully what you're seeing is that this diagram is a really useful tool to solve problems like this. So 20 or higher. Here's my first one here. So if I have a 5 on the first die and a 4 on the second, so I've got one there. I've got a 24 here, and then we've got 3 here. 1, 2, 3, and then 3 more here. So the probability of getting 20 or higher is going to be something out of 36, and I just count up how many favorable outcomes I've got. So I've got 2 and 3 here and 3 more here. So that's 8 out of 36, which is, we can divide both of those by 4. That gives me 2/9. All right, let's look at a second example, and then there's some Dr. Frost work where you have to make sure you can do the sample space stuff. Right, so now I've got a spinner, also very boring, 3 sections of equal size, and the colors are different. So there are red, green, and blue sections, right? So here's my spinner, and I've got 3 sections. Now they need to be exactly the same. So one of those sections is green, one of those sections is blue, and one of those sections is red, kind of. And then I've also got a die with 6 sides of the usual shape, so 1, 2, 3, 4, 5, 6, and I throw them at the same time. So list all the outcomes in the sample space. So this time all we have to do is this. Here we've got the spinner, and here we've got the die. So we can go R1, R2, R3, very boring, right? But we're just listing them all out. And the process of listing them means that we can solve problems with where we have to look at what might happen. So often the context for this kind of thing would be that you're playing some kind of game and someone bets that something will happen and someone else says, no, I bet this and I think I'm going to win more often than you are. Right, okay, so that's all the outcomes listed. And you can see that I've got 18 of them because I've got 3 colours and I've got 6 things on the die. Find the probability that I get blue on the spinner and 4 on the die. So let's go back to this big important formula again. Right, so that's the probability of an event happening. So this time the event is blue and 4. And that's actually, in this case, that event is the same as just one outcome. So blue on the spinner and 4 on the die is just this one here. So it's just 1 out of 18. Now the next question here, find the probability that I get green on the spinner and a number above 4 on the die. So we can write that as probability of green and above 4. So above 4 means not 4. So we're looking for 5 or 6. So pretty obviously, green on the spinner means I have to be here. Add a number above 4. Well, there are 2 outcomes, right? So it's going to be 2 out of 18, which is equal to 1/9. There you go. Probably one of the more boring videos I've ever made. Sorry about that. We will try and do some fun hands-on stuff with this once we're back in the classroom, but it's a little bit hard during lockdown. So all of this stuff is called working out theoretical probabilities. And what you should know by now is how to draw a sample space diagram and how to use this formula here and how to use this probability p bracket notation. Thanks for watching, and I'll hopefully see you guys soon.